Generally speaking, electrical conductors consist of a number of wires stranded together on machines such as these. The numbers run in the progression 7, 19, 37, 61, 91, up to the largest stranded conductor of 127. Paper was first used as an insulator by Dr. Ferranti. The first paper-insulated electric cable in Europe was made by the BI. Watch them being made today. After the insulation of the individual conductors, they are placed in a laying-up machine for the construction of cables containing 3 or more cores. The spaces between conductors are filled with jute, which gives a firm bed to the cores. Now another insulation of paper. As many as 70 papers, giving a thickness of 1/3 of an inch, can be put on in one operation. This machine is actually putting on 24 lappings. A slow motion picture shows you how perfectly the machine does the lapping. Now we come to the largest laying-up machine in this country, dealing with 3 cores, each insulated for 33,000 volts and covered with a lead sheath. The metal sheath on the individual conductors is to ensure even radial electrical stress on the insulation, a very important matter where high working pressures are involved. Spaces between the lead-covered conductors are filled in with jute. As the conductors and jute are laid together, you can see how perfectly they form, ready for the paper insulation. A thorough impregnation of the insulation is essential before the cable is covered with a sheath of lead. This hydraulic press forces lead round the cable, which, when formed, provides a sure barrier against moisture. We are now in the test house, where all cables are immersed in a water tank for a period of 24 hours. Any defects of the lead sheath cause ingress of water to the cable, which is immediately discovered when the cable comes to be tested. Cables are tested for insulation and subjected to a pressure test of several times the voltage at which they will be put to work. Between the tanks, they are measuring cables and cutting them to lengths to suit customers' requirements, which are governed by the distance between the joint boxes and other similar conditions. Lead, of course, is a protection against moisture, but lead in its turn must be protected against damage. So we have brought you to the armoring shop, where steel wires are laid onto a bed of jute strings. Another method of protection is provided by steel tapes, which are put on in such a manner that one tape covers the gap of the spiral formed by the other tape. So far, we have shown you cables used for heavy current. In this shop, cables for the transmission of the minute currents at low voltages used in telephony are manufactured. Telephone cables, instead of a few large conductors substantially insulated, consist of a number of small conductors, amounting in an extreme case to 2700. These are insulated with a single wrapping of dry paper. Another type of conductor, such as those used for winding coils of dynamos and motors, is covered with cotton. Cotton is received from the mill, wound in an elongated form called a cop. For use on the covering machine, it is necessary to wind it in the flat-ended form called a cheese. The cheese has a hole through which the wire to be covered passes. The cotton is rapidly spun round the wire at suitable tension by an arm revolving at approximately 3,000 revolutions a minute. The cheese paying off cotton as it is used up by the wire. The high speed is realized when we turn on our slow motion camera. This machine is shown revolving at only 1/10 of its normal speed. In many cases, conductors are cotton covered by braiding. Sometimes the braiding is put onto the bare conductor, and in other cases on top of a cotton covering. The merit of a braided covering is that it will not seriously fray, and that it is so easy to handle. As you see, the braiding is done on the maypole system. Just a minute. You can see more clearly through our slow motion camera. Here is a larger machine. We should mention that a braided covering is often impregnated with a compound of a character to suit the conditions which have to be met. The BI are particularly successful with the compounded braided wires which they supply for overhead lines in all parts of the world. We must also give ourselves a pat on the back for being the first to evolve a twin lead-covered wire for domestic installation. This machine is applying the paper insulation to the two conductors. Leaving cables for a moment, we'll glance at one or two of the other activities of the Prescot works. Resistance welders, for instance. Did you know that the BI manufacture all types of resistance welders? This is the bond shop. These bonds are used for rail joints on electric railway or tram lines. Nearby, a battery of drop hammers are forging bond heads. The BI make their own cable drums, and to utilize wood which would otherwise be waste, they have put down a plant for the making of firewood. A sideline, of course, but it has the advantage of preventing waste and showing a profit. We are now in the export department, where cable drums are lagged, painted and prepared for dispatch. Running along the centre is a battery tractor, so designed that the operator can, without assistance, pick up and transport drums of cable up to 5.5 tons. containing nearly 2,000 drums. You can see how the travelling Goliath crane facilitates the handling of drums, particularly in loading the lorries that convey the finished product from our Prescot works.